I want to show you how we calculate the pH of a solution made using a weak acid. In questions involving weak acids, not only do you need the concentration of acid in the solution, but you also need Ka, or the acid dissociation constant. The Ka tells you how much of the acid, when it's in solution, actually dissociates to give you those protons that you need for a solution to be acidic. Higher values of Ka make for more acidic solutions. Strong acids, in fact, have the highest Kas because they dissociate completely. Now, when I say higher Kas, I want you to be careful. 3.4 times 10 to the minus 4 is larger than 3.4 times 10 to the minus 6. When these exponents on the 10 are negative, 10 to the minus 6 is much smaller than 10 to the minus 4. Just be careful of that. But a typical question could ask you to calculate the pH of a 0.2 molar solution of hydrofluoric acid, and they will give you the Ka. Now, the first thing you have to do is set up this equation. For an acid that only gives you one H, Ka represents this value here, and I will do it for hydrofluoric acid. On the top you have the concentration of hydrogen ions times the concentration of the conjugate base, or what you have left over once you take a proton off of that. And on the bottom, what we have is the undissociated acid. And you see already, this Ka is a ratio between the amount that's dissociated and the amount that's not dissociated. All we know is that when we first put stuff into the solution, there's 0.2 moles of it. So, let's assume that it all starts as HF, since we're putting it in as HF. I know you guys may hate algebra, but there's only one way to solve this, and that is to assume that a certain amount, X of it, dissolves and gives us the H plus and F minus. If it gives us XH plus, it gives us XH or F minus, and we're left with 0.2 minus X of HF. Okay? We started with 0.2 of this. We now have less of it, and what we've lost of this, we've gained in H plus and F minus. So that is equal to the acid dissociation constant, and now all you need to do is solve for X. If you want, you can make mathematical assumptions, as your teacher may have showed you, or you can just use the quadratic formula to solve this. The quadratic formula will always work. In this case, what we're left with is x squared over 0.2 minus x is this Ka, 3.4 times 10 to the minus 4, or x squared, cross multiply this out, and eventually you can be left with something x squared plus something x plus something else equals 0, and you can solve that with the quadratic formula. What I would do here instead is make an assumption. I would say, you know what, this Ka is pretty small. I would assume that not much of it dissolves. If I assume that x is very small, then I can say that 0.2 minus that small number, it's about 0.2. We're not going to change it that much. In that case, and you would have to write this in full if you're doing a solution, you simplify your expression to this. Much easier to cross multiply. All of a sudden, x squared is just 0.2 times this number. That can just be put into your calculator. Take the square root of it, and you're able to solve for your x. Those are the two main ways to go about solving these, is make the assumption or use the quadratic formula. But in any case, once you solve for x, recognize that x is the concentration of hydrogen ions, and all you have to do to get the pH is take the negative log of that, and you will find out what your pH is.